Okay, we got two problems left. It's Friday afternoon. Hopefully I don't make a mistake on one of these. I am beat, really tired, so wish me luck. Find the power output for the decibel voltage gain of 4 decibels. Okay, so that means we're going to put 4 right there. We're going to put it into the function. We're going to put 4 right in there and figure out what the power output needs to be. Okay, so that means we need to jump over to Desmos and put that information in there. So I've got my Desmos open right here. I could go 25 and then E to the 0.1 times 4. Let's see if it lets me do that. Okay, so 37.3. What does it want me to round to? Doesn't really specify. On the test, I think, it'd probably be just fine to the 10th place. So it doesn't really specify, does it? I don't think it does. So 37.3, I'm going to say right here. 37.3. For the power output of 50 watts, what is the decibel voltage gain? Okay, so that wants us to take 50 and put 50 right there, right? So 50 is equal to 25 e to the 0.1 d. I divide by 25 and I get 2, right? I'm going to divide both sides by 25. These guys divide out. And I get e to the 0.1 d. Now I'm going to convert to logarithm. So that's exponential form. This is going to be log form. Natural log of 2 is equal to 0.1 d. Because see, since this is e, natural log means what do I have to raise e to get 2? What am I raising e to get 2? I'm raising it to 0.1 d. Now I divide by 0.1. So d equals natural log of 2 divided by 0.1. Here we go. Natural log of 2 divided by 0.1. And my picture's in the way. Here, let's see. 6.9 something or other. So my power output of 50 watts requires a decibel voltage gain of 6.9. Okay. So here are two answers. Now remember, like all these answers are in our textbook, right? So jumping over here, I think I got the answers over here. We just did, what was it? Problem. Oh, that's on the next page. AN 40 is what page you probably want to be on for this particular problem. And let me jump back over here real quick. We just did number 46, right? We're hoping to see 37.3 and 6.9 in there. So 46. There it is. 37.3, 6.9. Wasn't it 37.3? Is that what we had? Yes, it is. Look at that. So we got the right answer, right? That's what I want you doing, checking the answer. All right, last one. I think we're on the last one. Whew. Hope you have a great weekend, or having a great weekend whenever you watch this video. Okay, I took all this data and I jammed it into Desmos. And the Desmos that I put it into is right here. And it says it wants a exponential model for this data. So not a logistic function. This one, it says exponential model. It's, saying something like that right there, right? Okay. So now you notice like there's two separate forms here. This one has E for a base, and then it didn't specify in the other one. So I'm going to try Y1, the little tilde sign, A, B to the X. Okay, this is an exponential model with some kind of like random base in here. Now remember, we want this log mode turned on. Log mode is using a technique for calculating the A and the B that is the same as a graphing calculator technique, and it's what the textbook wants to use. And like I said, it's beyond the scope of our class on the least squares fit technique that it's using in this situation. So we're not worried about that. So the A is 2638. Okay, so let me put that down over here on my problem. The A is 2638, and it was like 0.3, let's say. So 0.3, and the B value is 1.04. So 1.04 to the X. Okay, that's my function. Now, if we're going to use the E, then we go like this. We go down here and we say y sub 1 tilde, and we go A e to the kt. All right. Oh, wait, not kt. We want kx sub 1. Otherwise, it won't use our data. And now we've got 2610 for our A, and our K value is 0.04. So 2610 e to the 0.04, 0.04x. And again, these rounded numbers that we got going on are somewhat bad form. Hey, look at that. It's kind of interesting, right? Maybe study that a little bit. Kind of fascinating. Graph the exponential function found in part B or C on a scatter diagram. I don't really know that I'm going to have you do that on the test, but let's take a look. What does it look like? If I go up here, remember, I can hit that little magnifying glass and it shows you, boom, there it is, right? Here's our initial value at time 0, 26, close to 2684. It's not exactly 2684 because it doesn't perfectly go through all these points, right? So, quick little sketch looks like any increasing exponential function, right? Now it says predict the academic year when the average tuition will reach $12,000. So you could graphically solve this. We've talked about this a bunch, right? Y equals $12,000. Okay, so I can come over here and put in y equals 12,000. Y equals 12,000 and hit click, and it says, now which model do we want to use for this? I think we should use this one. Oh geez, I got to get the logistic function, the log mode turned on. So it won't matter if we use log mode on both. It should give us the same exact answer. So 37, about 38 years. Okay, so let's put that down, 38 years. And I've been stressing that you need to solve algebraically as well, right? So we're going to take the number that they told us, 12,000. I'm going to put 12,000 here. And I'm going to put this is my A value, right? So I'm going to put A e to the kt, and I'm going to just use the A and the K. So I'm going to divide by A. So I get 12,000 divided by A is equal to K. Oops. Hold on a sec here. E to the kt. And then I'm going to take the natural log of 12,000 divided by A. And that's going to be equal to kt. I just converted to log form because this was saying e to some power is equal to this number. This is saying e to this power is equal to that number. Now I'm going to divide by k. So I get 1 over k natural log 12,000 divided by A. Let's see how it comes out and see if it compares to this 37 number right up here, 37.9, right? So I'm going to go... what did I say? 1 divided by k, and then I'm going to have the natural log of, what was it again? 12,000 divided by A. So 12,000 divided by, I don't like that. I want to have 12,000 divided by A and take the natural log of that. Okay. Ooh, it is not liking that at all. I have a feeling that because we have A and, in two different places and it's the same number, I think if I delete one of them, will it work down here? There it goes. It was because it was in two different places. It was kind of freaking out a little bit. So 37.993. Perfect. That's what we wanted. And we can confirm that from the textbook as well, right? So like if I look right here, and we were just doing that one, I think, weren't we? Where'd it go? What number were we just doing? 56. So 56, where the heck is 56? Here it is right here. So yep, everything's checking out right in there. Between 2021 and 2022. Oh, that's right. See, we've got an answer of 38 years, but that means we got to add 38 years to, to this number, or we add 8 to this number right in here, right? And that'll take us to the right spot because it's 8 years past this number. All right. Well, I hope I made that clear where this came from because, adding 8 to 2013